So for the most part, I'm going to be going through Ros today. Let me make sure that I hit that. I'm going to be going through Ros today with mostly the only assumption I'm going to have is that if you're trying to follow along, you're going to have it already installed, because I'm not going to run through copying and pasting commands. If you have trouble installing, reach out to someone to try and help you install. That sometimes can be really annoying, but once it's installed, that's kind of where I'm going to start. As far as this goes, please interrupt me or put stuff in the chat and Jenny can interrupt me. I'd rather answer questions than just blanketly talk. If I just blanketly talk, you may as well just watch the video online. So does anyone have any questions before we get started? All right, so let me just share my screen here. All right, so I'm gonna go over a little bit about like what even is Ros before we get started and why the heck do we even have it. I'm gonna try and get a better background. So people ask, why would we ever even have this Ros thing? There's lots of different answers to that, but the original motivation is, let me just draw, there we go. We have some sort of robot. This is what the robot I work with looks like. And at the end of the day, we can write programs on this robot, right? Some sort of program for, let's just say, to move the wheels. So we can move this robot and move the wheels, right? Cool, great. We can write all of our internal programs and make this really big set of junk. And after a while, that seems great, works really well on a robot. But let's say we want to have a second robot here. And now we need to communicate between these two robots, right? So this is actually not a super simple answer of how to do this. There's many different ways to do it. One of the big things you'll hear a lot on how to do this is using something called sockets or web sockets. Essentially, what that kind of is you can go over Wi-Fi or any sort of network and write in your program, say it's some Python program, basically send this string of potato over to robot 2, right? And it'll go over Wi-Fi through these sockets and go over here. And it'll receive the potato message, or more likely, like, what's my location right now? Like, here's location of me, like tell robot 2 where I'm at, right? So setting up these sockets, for anyone who's ever done it before, super annoying. Really difficult. And you would imagine once you get a third robot, it starts to get kind of tricky, because then you got to do all these connections between different programs, and you'll have multiple different programs running on the robot and multiple different programs running between all of the robots. So in comes Ros, which I need to remember how to use the eraser well in here. Assuming no one needed that. And if we go back to our original robot here, what we want to do is create kind of contained programs that can, so we're going to do a program about something called odometry, which is the X, Y location of the robot, and it'll also have the rotation. So this program that you're writing is going to keep track of where the robot is. How it does that, there's many different ways upon the different robots. Some of the cool things for anyone who's interested, something called a wheel encoder, and you can look that up. It's when like light shoots through a wheel and it figures out how many times wheels have spun. But essentially this odometry program is going to try and keep track of these things. And you would imagine a lot of programs are going to want to know in your robot, where is your robot? So this little program, we can think of as Python, has this internal data of X, Y, and rotation. Let me clean up a little bit of stuff here. And now we want to write a separate Python program that I don't know, decides if it wants to move the robot or not. So if we're at 0, 0, move, else don't move. Not that exciting of a command. It's if we're sitting at our start spot, move us away. And if we're not sitting there, don't move away. We're going to want to somehow, while this Python program's running as one process, we're going to want to get that information over this way. And how we do that is through something called a Ros master, which you can think of at first as kind of magic, because in a way it sort of is. Essentially what we do with our odometry programs, we run this, and this will be called something called a Ros node. Oh my goodness, I was between writing two different words. This will be one Ros node. And when you run this, it'll connect to the Ros master. And I'll show this in code, exactly how that kind of works. And what you'll have, let me erase this, is you'll run this as well, the separate program, which will spawn a Ros node, and that'll also communicate with master. And what this odometry program will do is publish the odom message. So you'll hear something called publish subscribe a lot. This is a type of networking protocol. Essentially, we have, oh my gosh, I'm gonna say the word essentially like 900 more times, I swear. We have this idea of we have a program that knows something and can publish it out. So that's basically just sending it out to whoever wants to subscribe to this. So one program that wants to subscribe to this is this weird movement program we wrote. And we can subscribe to whatever this is publishing. So you'd imagine some sort of while loop in here. Just while one. Just keep publishing odom over and over again. And then this will subscribe to odom. And we'll be able to use that data. And now, because we have something like that, we could write another program that, I don't know what it does, but another Ros node that also subscribes to odom. And it will go up to Ros master, and it'll tell us the odom every time it publishes. And if we had another robot, we can write another Ros node or program that also points at the same Ros master. This Ros master is literally just a program running on this robot and asking for the odom and using it somehow. So everyone can subscribe to this published topic, and this thing can just keep publishing, and whoever wants to subscribe to it can subscribe to it. Does that kind of make sense? Any questions on that?
Yeah, is there a difference between like input versus output, or like sensors versus actuators in terms of nodes, or are they all just nodes?
So it's a good question. As far as like actuators, sensors, stuff like that, I'd like to think of anything that you'd publish or subscribe as just data at the end of the day. So if you imagine like print console, like if you ever printed something, like it doesn't matter if you're using, or how do I describe that slightly better? You're just sending data. So there's different types of data that you can send and subscribe to. If it's an actuator, such as like, I don't know, an arm joint or something that you want to move, you can publish a command to the arm joint, and the arm joint program will be subscribing to that, and it will be a type of message. Like, I'm forgetting what joint messages even are right now off the top of my head. Whereas sensor messages, like from the camera, if you have a little camera on your robot here, that will continually publish some camera feed. Now that's super slow, but it'll just publish it, and whatever program wants to subscribe to it, that your arm joint program could subscribe to that for all you care about. If that makes sense. Does that kind of answer your question?
Yeah, totally. Thank you.
Yeah, of course. Other questions?
There's a question in the chat. Devin asked, is the published data persisted on the master through a database or something?
The internals of Ros are very interesting. I'm not an expert on the internals exactly. It only publishes, and I'll have to 100%. Yeah, there you go. They're not. When you subscribe, it'll only get it in like real time, if that makes sense. So like stuff isn't stored in any sort of way. When you subscribe, you can subscribe to Odom and you can start, oh my goodness, that's the eraser. You start to build up all the real-time messages in some sort of queue, and then you process out that queue like as if it was like a big queue of just data coming in. But no, it doesn't like store anything in the Ros master. This is also not exactly how this works, where it like connects to Ros master and everything goes through Ros master. Ros master does some coordination and network coordination, but from a theoretical conceptual point, you can just think of everything publishing to master, which does all the quote unquote network magic. And then when you subscribe, it'll just send the data in real time, in quote unquote real time. Any other questions? All right. So this is kind of the motivation behind Ros. A lot of it's this idea of abstracting out programs. So you don't have to rewrite your odometry or your whatever inside of every other program you have. You just subscribe to the program that is keeping track of the odometry for you, as well as multiple robots. I'll be covering Ros 1, which only has one Ros master. Ros 2, you can have multiple distributed Ros masters. I already got the question of why aren't you using Ros 2? Ros 1 has more support than Ros 2 does. So if anyone's ever used any library in their life, you're going to choose the one with more support and the one you're more familiar with. The industry may or may not be transitioning to Ros 2, but that Ros 2 has been around for like since I was an undergrad, like 6 years ago or something. And there's also a direct port from Ros 1 to Ros 2. And Ros 1's a little bit easier to explain. Most of the stuff we'll be going over here, like with actual code and stuff, is kind of the quote unquote simplest method of programming robots in Ros, just to get familiar with the different types of things. I will actually not be covering services because I think they're a waste of time to first learn. I think pub/sub is the way to go when you first learn, and then you learn that services are better. But pub/sub conceptually makes a lot more sense.
Oh, quick question.
Mm-hmm.
Just to make sure, you can publish to multiple Ros masters and you could subscribe to multiple publishers, if that makes sense, right?
So when you publish, you can have one program publish multiple topics. So this is called a Ros Topic. /Odom, I'll put slashes in front of them, is a Ros Topic. You can publish and subscribe to multiple Ros Topics. There will only ever be one Ros master, but you can publish and all right. So we have no Ros core running. We've sourced our opt indigo setup.bash. And what we're going to do is make our first Ros package. So we're going to make a directory, potato workspace. It doesn't matter what this is named. You can name it whatever you want. It looks like, according to the Ros tutorials, that you have to name it very specifically. Where's the Ros? To Catkin workspace. That is not necessary. You can name it whatever you want. Where's it? Creating Ros package. Move this over here. There we go. And all you need is to make a directory inside of here named src. That does need to be named src and catkin make.
What is catkin make?
Catkin make is Ros's build system. So Ros at the end of the day is a glorified build system of all these packages. So if you remember in that opt Ros indigo share folder, there's all these packages. Building packages and dealing with dependencies is really annoying and really difficult, especially in C++. So that was what Catkin's for, is dealing with all these interdependencies and being able to build your own package. So Ketkin makes a really complex build system, essentially. So if anyone's ever used Make before or CMake, it's built on top of CMake, as well as a bunch of other stuff. So whenever you have that SRC in here, you'll notice when you run Ketkin Make, you have a build devel. There's really nothing in here. In our SRC, we have a CMake list with nothing in it. This was also auto-generated with a bunch of junk in here. We just have an empty workspace. So if you're looking to just make an empty workspace, this is how you do it. And if we want to make a package, that'll be the next thing we do. We're going to CD to the SRC, and this is where we'll end up making our packages. And all you need to run is, where's the Ketkin that I always forget? Here we go. Ketkin create EKG. And then we can name it. I'll name it makers. And then you need to put what this package will depend on. So this isn't the only time you ever need to do this, but one Ros package is going to use a lot of other Ros packages. So when you make a Ros package, which will be full of your programs, which will create nodes, you're likely to use at least Ros Pi or Ros CPP or standard messages. So it will, yes, Jenny.
Okay, so just to like recap everything that's happened for people who've not worked with Ros, where are you making the workspace? Like, I'm assuming this is like your root directory, right?
Yeah, and you can make this workspace wherever you want. It really doesn't matter. So you could make a directory that's this, CD into it, and then you can make it another one of WS, CD into that. And as long as you make an SRC and you run Ketkin Make, now we have a new workspace. Most people put it on their top level directory because it's the easiest thing to do.
Okay. So just as long as you have a source directory, then it'll recognize it as a Ros workspace. How does that work?
So Ketkin Make. So what was the directory that they even put it in? The potato workspace, right? You said, yeah, so when you run Ketkin Make, all it's looking for is an SRC directory. And what it's going to do is go into that SRC directory, and it's going to be looking for all of the packages in here.
Gotcha.
And auto-generate the CMake list for you, and then auto-generate these build and develop folders for you.
Okay, got it. So just to recap everything, you're going to make a workspace, you're going to CD into it, so you're going to go into it, you're going to make a source folder, and then you can run Ketkin Make with the dependencies that you need, and it's going to depend a little bit, but you just use the ones that are really popular and like people are most likely to use. And then with that, we're here.
Yep.
Got everything? Okay, hopefully that.
So then we created a package. This is the package that you'll make if you do the beginner tutorials. It's Ketkin create package, name of the package, and then other package dependencies. And instead, I called it makers. So when you do that create package, it'll auto-generate another CMake list and a package XML. And if we look at that package XML, well, you'll notice there's a ton of garbage that you can just delete that's auto-generated for things. I usually delete all the comments out of these. But here's your build depend, Ros CPP, Ros Pi, standard messages, and then build export and execute depend. This is what the create package will do for you. So you can manually build this package XML. You can manually make all of these build files, but that's really the quote unquote benefit of Ros, is that you don't have to make all of these build files yourself and create them. These are kind of the tools to make them easier. Other things in the package are the CMake list, which again, same thing. It finds the dependencies, builds all those dependencies for you. The most common dependencies at the beginning that you'll be working with are Ros CPP, which is the Ros CPP stuff, so C++, Ros Pi, and standard messages. So something I have neglected to say, Ros Messages, all those Ros topics that you're publishing and subscribing are all different types of messages. So you'd imagine you want to send different types of data. Strings, Booleans, cameras, images, all of it is different types of messages. There's Booleans, there's integers, there's float, string, time, vectors, all these different things, right? So way back to the beginning, Odometry Message Ros, if you just Google this, here's what an odometry message looks like. It's a JSON of this header and then a bunch of other stuff, which is other messages of messages of messages. So what we're actually going to stick with right now are just string messages, which is standard messages packages string, which all it has is one thing inside of its JSON, which is data. So, and I'm going to cheat and just copy paste the Ros code because I am build a Ros package. Oh yeah. So to build, you must be in the source directory. You do catkin make, and assuming you don't have any package issues, you'll see nice green. And we made our makers package, which has nothing in it. But this is just kind of something you need to do to build your packages and make sure that all your build dependency makes and all that don't have any issues.
So kind of zooming out a little bit. What is the relationship between packages and Ros nodes? Like, are we trying? Do we build a node in here? Do we like define it in here, or is a package always just going to be a node?
This is what I should have started with at the very beginning. All right. You have Ros packages. You have nodes. These all have Ros in front of them. You have topics. And you have Ros messages. So, and there's more Ros insert thing. Ros package is a set of programs that it's kind of your all-encompassing. If you were to download like a program, it's kind of one program. So you'll have something like a navigation package. And this package has multiple different things inside of it. You'll have different programs that you're going to be creating. So let's just make one program here. And in that program, you're going to be creating Ros nodes. So you'll generate Ros nodes. And you'll have another program doing the same thing. And your package could have multiple different programs. And you could run all of them, you could run just one of them. But a package is like an all-containing thing for usually one thing. So navigation, vision, odometry, stuff like that. Does that kind of make sense for package?
Yeah, so it's like analogous to a Python library.
Yes, I can't believe I couldn't think of the word library. Yes, it's essentially what it is. You're creating your own library.
Awesome, that makes a lot of sense. Thank you.
Yeah, and then these nodes will either they can publish and subscribe to things. And they publish topics or they can subscribe to topics. So nodes can publish and subscribe to multiple things. Sadly, you can create multiple nodes inside of a single program that publish and subscribe to multiple things. A lot of time you'll see, from my experience, you'll see one node being created that will publish and subscribe. And those will all be to topics. And a Ros topic is essentially data that you're going to be writing to what I'd like to describe as you're going to be writing to the Ros master. Think of it as like a blackboard. And let's say the topic's name is Odom, and it has some sort of Ros message type here. And we're using string type, so all it has is something called data and some sort of string, so probably X, Y. Does that make a little bit more sense? Questions on that? This is probably the most important part of this because I'm like drilling way too far in, I feel like.
So Ros master needs to be defined specifically for a particular machine, and we can define Ros packages that have nodes and topics published by nodes that we can subscribe to.
Very close. Most of that was right.
Okay.
Except for Ros master, you need one running on some machine.
Gotcha. Okay.
So if you do this all on one computer, you'll be running Ros master just on the one computer. And these programs will create nodes that will publish topics, and those will publish over to Ros master. But if you have a second machine, so say this was all run on machine 1, if you have machine 2 creating nodes that publish topics, it can decide to publish over to this same Ros master. So Ros master and Ros 1 only runs on one machine.
Makes sense.
Questions about this beautiful diagram with amazing drawing?
So the Ros messages are basically commands that we're trying to run, right? In the Ros master.
Close, not necessarily commands, they're just data that anyone can subscribe to and do whatever they want with that data. So you can publish the XY of odometry, or you can publish a command velocity. So I want to publish to this command velocity and say, okay, whoever's subscribing to this, I want you to move a foot forward. But that doesn't mean anyone subscribing to it has to move forward. It just takes that message and does whatever it wants with it. It's basically a big posting board. It's what you can think of it as. And people just post data there with publishing, and then subscribing as you look at that board, look at whatever's been posted recently, and you can do whatever you want with that data. Does that make sense?
Yeah, but so what's the difference between messages and topics then, if they're both data?
So Ros topics are the actual, like, messages are, that's a great question. Ros messages are essentially inside of topics. Like topics have a name and then a topic or a message type, sorry. So if you thought of a topic as a class, it has a name field and a message type. Does that make sense?
Yeah, thank you.
Okay. Other questions on this?
There's one in the chat. I can read it. It says, does your code go in the packages? Nodes are like a process running on the robots. Topics are kind of WebSocket's endpoint, and the message is a thing being pushed.
Yes. Yes, that's a very close. Yes. Wait, was that a question or just a statement? So
I think he was asking where your code goes. Like, do you directly modify the packages, I think.
Oh, where does your code go? Okay, great question. Are there other questions on this diagram before I actually write Ros code for the first time, which is what I should have started with this diagram and then just wrote Ros code. All right, so I need to log back into my, so there are, let me clear this. There are Ros packages online. There are Ros packages other people have made, and we're making our own. So, oh my goodness, where's potato? So we're writing a makers package, which we just created by just doing the, where's the building packages? Where's the create command? Where is it? Cat can create package right here. Oh my goodness. So we created this. That's where all these files came from. And now we're going to actually write code inside of our package. Right now we have no code. So inside of makers and inside the source, there's nothing. This is just all boilerplate, which is why Ros is so tricky. Is all this boilerplate is annoying, but also somewhat necessary. Build Ros package. Where's the tutorials? I'm just going to create the boring one. Where is it? Topics, parameters, blah, blah, blah. All right, I'm going to write it in Python. We're going to write a publisher and subscriber. So I'm going to be a super bum and copy paste it and then go over what it actually is. So typically you'll see C++ files inside of SRC and you'll see Python files inside of scripts. It's not necessarily always that way, but for the most part it is. So I'm going to make our first Ros program, and it's going to be a publisher. So this is something that's going to post to the Blackboard, basically. And we'll run over what all this code is line by line real quick. So start main, runs Talker, not that exciting. So Ros Pi publisher, chatter, string. This pub object is the Ros publisher. We also need a Ros node. So the person who wrote this, in my opinion, should have written in this order. Pretty sure should still work. And like 95% sure. So we create our publisher inside of our Talker node, and we're going to run it at a rate. This isn't anything fancy, it's just 1 divided by 10. So we check is the Ros Pi.is shut down, checks is the Ros master continually running. If it's not, the while loop will break. It's going to create a hello string. It's going to print that to the console, and then it's going to publish it, put it on the Blackboard, and then it's going to sleep for 1 divided by 10 seconds, which is this rate. So we need to, anything with Python, you need to make an executable, which you do chmod. It'll turn green if you have colors turned on in your command line. We need to build our package, which now we're in the top level directory. That can make. And we need to source val setup.bash. This will add our potato workspace to our Ros package path. So here's our Ros package path, and you'll notice that home, Tigrache, potato workspace, SRC has been added. So now we can actually find our own package. So if we want to Ros CD to our, what we call makers, we can go there. Now we can do Ros run, package name, which is makers, and then talker.py. So Ros run runs our program, which will init a node and publish stuff. This is the package name, and then talker.py, which is the actual program. There's no Ros core running. Happens all the time. Ros core. So now once I start up Ros core, this printing out to this command line here is this Ros Pi log info, hello string. That's line 12 here. It is not the actual publish. So if we look at Ros Topic list, you notice we have chatter, which is the name of the publisher. The topic is the name of the Ros topic for the publisher. We can name this whatever we want. If I stop this and rerun it, now we'll get the brrrr. Make sense?
Yeah, so just as another quick recap here, you wrote the code for, this is the publisher, right? Because it's going to publish the Hello World thing every 10 something.
At 10 hertz, yeah.
10 hertz. Okay. Sorry, there's a ice truck. Then just to verify, like you have to make that into an executable, and then you go into the root of your workspace, and then you have to run cat can make to compile it and put it back onto the, or I don't know if this is one step, but you have to put it onto the path as well, right?
Yeah, so you'll just need to make sure you source your devel setup.bash, and that'll add your current workspace and all of its packages to the Ros package path. So when you do Ros run, it can just find it. Or else you'll have to CD all the way. You can do this. You can CD to source, CD to makers, CD to scripts, and then Ros run talker.py. Why can I not talker? You should be able to still do this. Oh, you do need package path for Ros run. I hate everything. This is what I get for. You can do that with launch files. That's a good recap. I commented out line 12. The nice thing about Python is you don't need to rebuild your package every single time. If you're doing C++, you do have to run cat can make again every time you change something. Python, you do not, because it's an interpreted language. You'll notice that it looks like nothing's happened. That's just because I took the log info out, but it's still publishing hello string. So if I do Ros Topic list, and if I do a Ros Topic echo of the W whatever, here is what's actually being published. All these three three dashes mean a new message. So data of hello world, and then the time, which is hello world, and then the Ros Package time. That makes sense. Questions on that? Then we'll subscribe to it. And then I'll quickly show Real Robot being published to and subscribe from. So that's the talker. And now I need a new file for, this is what happens when you have too many things up. Here is the listener. This is just copy and pasted. Get rid of all the comments. All right. So we're going to subscribe. We're subscribing to, so we're going to init a node because you need to be on a node. And we're going to subscribe to Chatter. Anyone see a problem with subscribing to the Chatter topic? If we look at our Ros topics that are actually being published right now, what's being published to the Blackboard? What's the topic name? It is not Chatter. It is this whatever spelled incorrectly. So we're going to subscribe to the whatever topic. The topic type is a string, which is from standard messages.message import string. And it gets a callback function, which we can call CBABA, doesn't matter what you call it. It's just a function. And every single time that it receives this message, this callback function gets called with the message going into data. So if you were to cd Ros, did I chmod it? Probably not. All the way there. make sure to build. I need to source the devel setup. You'll do this too, I promise. So this is the listener, just Ros Pi login pulling everything, which basically is just print. You can literally use print instead if you wanted to. Print data. There you go. This is also a terrible name for this. It should be MSG and MSG.data. There you go. And if I stop talker, it stops. And that drawn out just looks like, oh my goodness. Where's the white background? That's white enough. All that looks like is you have talker publishing to whatever on the blackboard over and over, and the listener is subscribing to whatever. And we could make another, we could run another listener over here also subscribing to this, which is kind of the full benefit. So if I Ros run that one, Ros run talker, and I do yes. And I do Ros run makers. Now we have 2 subscribers to the same thing. And you're gonna have basically infinite number of subscribers. I mean, you'll lag out your system, but you can now subscribe to any of those things. Any questions on that? Then I'll show like an actual robot.
Wait, Tom, in the interest of time, I do know that people go past 5. So I think what we might be able to do is like take a question session for the basic like publisher and subscriber model, because hopefully this will be enough to like get people started.
Yeah.
And then I can stay behind, and then you could record the robot demo with me and forever who can stay behind, and then I can show it at general meeting or something.
Yeah.
That sounds good. So if people have to go for class, they can, but if you have any questions about the publisher subscriber model, you should probably ask it now, because this is like the heart, I think, of what you guys will be
doing. Just out of curiosity, can I get like a 1-sentence like description of services? Just like a little preview of how it's different. Is it possible to do that in 1 sentence?
In 1 sentence, I would just say, if you're comfortable with PubSub, like it's client server based, so if you ever worked with that, then it's basically that. So instead of continually publishing all the time and subscribing constantly, you don't want to be doing that for really heavy tasks constantly, and they're set up slightly different. But if you understand PubSub, then just go look at the Ros services.
All right, sounds good.
But yeah, I would recommend anyone who's learning, and also I understand a lot of this was mildly confusing. Definitely just skip to the PubSub stuff first. Use that, and then once you're comfortable with that, then look at Ros services, because they are better for a decent chunk of stuff. Any other questions?
This is a question I also had. I think I like missed it, but do you have to run talker and listener at the same time along with Ros run? Like you have to run all 3 of them for it to like publish, subscribe, and run correctly?
Yeah, so you always need Ros core running. You need Ros core somewhere on one of the machines, and everyone to point at the same Ros core. And then you can run as many talkers or as many listeners as you want. So you can have multiple things publishing to the same topic, and you have multiple things subscribing, which you would imagine a lot of the time you have one thing publishing, and multiple things subscribing is one of the most common models, but that you're not limited to that. So you could have kind of unlimited of both.
Gotcha. Can you show how you run the talker.py again? I just don't remember.
Yep. So it's Ros run and then the package name. And then, oh, that's listener, but just talker.py. And
So, sorry.
No. What are you gonna say?
If we talker.py in two different terminals, would that just be two publishers doing the exact same thing, or would it recognize that it's just like this and not do it?
I've never done it, but I'm pretty sure that's what it would do. Yep. There you go. And then if you do Ros Topic info on what the heck is this even called? Who named this thing? There we go. It'll tell you all the publishers towards that topic and all the subscribers.
Gotcha. Very nice.
Yeah. So the most common commands I use are Ros Topic list to tell me all of the topics. There's a bunch of different topics that'll happen. And Ros Topic info, and then whatever you put the topic name there. And it'll tell you what the message type is. So you can do Ros MSG show, and it will show you what that message looks like. Trying to think what are the other ones I use. Same thing with Ros node. So Ros node list, and here's talker. The first one that I'm running, probably this one, and here's the other one, probably this one down here. And you do Ros node info talker 32. Let's just choose one randomly, and it will tell you. Oh my goodness, let me make this. I forgot the command for full screen now. I'm getting old. Publications to this, and that's its node. Ros out services. It has logging services. But yeah.
And do you have any advice for project teams about if there's any difference in functionality between Python and C++ versions, or is it just whichever language we like better?
Yeah, so that's a great question. The great thing about Ros is because these programs are all contained. So when you write, I can write a publisher in Python and then write a subscriber in C++ and run those separately. So that's one of the best advantages is everything's very modularized, for lack of a better word. Or I mean, that is the word. But yeah, so write whatever you're comfortable in. I would hesitate towards using, well, yeah, write whatever you're more comfortable in or your team's more comfortable in. I would go with whatever the lowest common denominator is, which is usually Python, but I guess this is C++ school too, so maybe not. You have more build issues with C++ is really what it comes down to, but Catkin's theoretically supposed to get rid of that.
If you were to, because right now, like, you're just using instances like on your machine, right? Like if you wanted to get robotic input or something, how would you go about programming that?
If I wanted to get robot input.
Or you want to like send it to a robot, like how do you specify?
Great question. So I have a robot sitting next to me, and let me grab it here just to show it on the camera. This is what the robot looks like. I should turn my whatever off. I don't know how to turn virtual stuff off. Video settings. Where's the? Man, I'm getting old. Backgrounds and filters, none. All right. So here's the robot I have sitting next to me. There's a Ros core currently running on this. So I'm going to put this down for a second. And I'm going to SSH into the robot. So this robot's on the exact same Wi-Fi as my current computer. PS aux Ros. Okay, so there's nothing running on the robot right now. So, there's something called launch files, which I haven't covered at all, but you'll get into. You'd imagine running Ros run a million times is super terrible. say you wanted to run 12 different programs and you want to run them all at once or in sync, you create launch files, and these launch files run all of these ROS runs essentially. So, oh, I can't spell ROS launch. Oh, source, of course, I don't have the correct sourcing. There we go. So if you remember, so this terminal here, let me close this one. This terminal here is on the robot. On the bottom here, this is the robot's terminal. Grep, and there's something called the Ros Master Uri. This is where's the master at, basically. So if I'm going to foreground this real quick, and I'm going to do print and here also. And the Ros Master Uri I want to run on the robot. Here is the IP of the robot is 192.168.1.250. You can find that doing ifconfig grep 192 most of the time. And here's the address of my robot. So this is its internet address. And that's where I'm going to run the Ros Master Uri. And then, so when I do this launch file, it auto generates a Ros Master for me way up here. Oh my goodness, there's so much junk on this robot. So this is it, running it, and then starting up all of these Ros topics. Lots of Ros topics and services and stuff like that. So right now, my Ros Master Uri is a local host. So it's on what is this current computer. And if I do Ros Topic, Ros Topic list, there's no master running on my current computer, right? So I need to export Ros Master Uri equal to HTTP. Did I do that in the right order? I always forget. I need to make it, no, I didn't. Yes, I did. Okay. 192.168.1.250 at port 11311. Now if I do a Ros topic list, I have all the topics from the robot. Because essentially what's happening, oh, I can just highlight it, makes it white. This is the robot. The Ros masters here on 192.168.1.250. And I need to tell the actual computer to point it here. So, and you set that through Ros Master URI. Does that make sense? And now I can write programs that will publish and subscribe to these things. So I can do Ros Topic echo odom, which I talked about way at the beginning. And now you'll see it's publishing this odom message, which is like a ton of crap on it, which has this twist, which is an X, Y, Z, and an angular, and it has a covariance matrix. It's like way overcomplicated for no reason. Well, not no reason, but. And when I move this robot around in real life, that's the robot's location. This Ros Topic echo is essentially a subscriber. I mean, it is. Just without writing all the Python code, because I was too lazy to write it. And if I want to do Ros Topic hub, and I want to do command val, this is the message that moves the robot. So if I do, I think it's the X that will change it. Put it on my desk here, and I run this. Should. I've never broken a robot, I swear. Only a few. And I publish that. Should move my robot. Now, I didn't turn off the IP tables and stuff. That's fine. But yeah, basically you can publish from, this would be on the local machine, and then this would be the robot receiving it. What this command does is essentially gets rid of sudo iptables-f, turns all of your security and firewalls off, which is what all roboticists do because they're too lazy to deal with security. And sending these messages over a network, you would imagine, isn't very kosher because everything's over HTTP. If anyone knows anything about computer security, it's not very good. That's why there's a lot of open ROS ports online that you can actually send commands to from your desk that you're sitting at right now. For unprotected networks. There's people who troll the internet to look for open ROS ports, which can be really bad if you have a robot worth $500,000 that you could just run into a wall over and over and break it. Let's see if I can get the other questions. Does that answer your question, Jenny? I did a massive long thing, but.
Oh yeah, for sure. So just like another high level recap. Would it be fair if I say like the ROS core is running on your local machine? Yes. Hopefully.
The ROS core is actually on the robot. So I didn't explicitly run it, or I'll do it. But ROS core ampersand, and now the ROS core is running on 192.168.1.250, which is the robot. And
why
then,
is it running on the robot?
you can run the ROS core on either. I forgot what the benefit of running it on the robot is, to be completely honest. I've always run it on the robot. But that is not out of any specific reason other than that's what I've always done. You just need it to be running somewhere, and everyone needs to be pointing at the same Ros Master URI.
Gotcha. So you've SSH into the robot on the lower terminal, and then
Yep.
the upper terminal is your local machine. And then I think your robot has been like publishing its location. That's what you showed us, right? Or the geometry.
Yeah, the odometry, yeah.
Gotcha. Cool. And then the sudo tables F is just to turn off like the security things. So
Yeah, security and firewall and stuff. Yeah.
Gotcha. Yeah, I think that makes sense. Or yeah, on a high level it does.
And this Ros Topic pub right here is basically the same code as this talker, but you're using a nav message twist command val. And instead of writing a string, you're writing a command val message. Just let me clear this off the screen. Which I won't be able to get Curie to run necessarily, but. Other questions? I'm just going to be running the turtle sim in the background. Other questions?
Yeah, thanks for the tutorial. I guess if that's it for the questions, we can wrap things up here. Tom, do you mind staying behind? Let me end the. Do you mind staying behind so I can